So we have this Morgan, and they're out for a walk in Chicago, and they're walking to Willis Tower. And so they're walking along, and they measure this angle of elevation. And I'm just going to assume that, I'm not going to take into account Morgan's height or eye line or anything like that. I'm just going to say from Morgan to the bottom of the tower, something like that. And that's a 3.6 degree angle. Okay, now she walks a little further along, and now, got taller obviously, and now this angle is 4.2. Okay, so here's where it gets kind of tricky. We don't have, all we have here is how far Morgan walked. So this is 1. We don't have how far it is to the tower or how high the tower is. Those are both things we want to find. So let's call how far Morgan is from the tower after the second measurement x. And we're going to call the tower y. Okay, everybody okay with that so far? Okay, so I shrunk it down a little bit. We could see the picture here in the lower right-hand corner now. Let's start with the first triangle we see. The first triangle that Morgan had was this triangle right here. Okay, if we had this length, we could easily find the y using trig functions. We don't have that complete length, but we can still write an equation with that length. So first of all, what trig function would I use from the 3.6? Sine, cosine, tangent. What sides do you have from the 3.6? Here's 3.6. Right, we use tangent. That's the opposite. That's the adjacent. So we got to use tangent. So we'll go tangent 3.6 equals, and what would my equation end up being on the right side? Y over 1 plus x. I'm good with that. Okay, so that is one equation. Now Morgan walks along 1 kilometer. Now they're at the 4.2 angle there. So how would we write a trig function from the 4.2? Tan 4.2 equals y over x. Okay, so now I'm looking at these two equations, and I see they both have a y in there. That's kind of nice. There's just the y by itself. So what I can do here is make both equations a y equals equation. So, and I can do this actually with taking tan 3.6 and tan 4.2 degrees and getting a decimal for that. That's a little easier to work with. So, because tan 3.6 is just a decimal. So what did, calculator really quick, what's tan of 3.6? 0.063. And what's tan of 4.2? I want to say it's 0.073. Okay, so that means for this left equation, I could have y equals point 0.063 times 1 plus x. On the right equation, I could have y equals 0.073 times x. Okay, everybody see what I did? On the left equation, I just multiplied both sides by the 1 plus x. And on this equation, I multiplied both sides by the x. Questions so far? Okay, they both equal y, so how can I solve for x now? Yeah, so we could use substitution, set them equal, and we would get 0.063 times 1 plus x equals 0.073x. We can do some algebra here. Get 0.063 plus 0.063x equals 0.073x. We can subtract the 0.63x from both sides. We end up with 0.063 equals, and that's just 0.01x. Divide, and what does x equal? 6.3. And what's the, what units are we in right here? Kilometers. So 6.3 kilometers. So this would be 6.3 right here.
Yeah, how do you know? Oh, you divide by it.
Okay, and now Morgan's at the 4.2. How do we set up a trig function equation to solve for y?
Plug in x.
Yeah, plug in the x to, well, we'll just do the tan 4.2. So yeah, we could plug in the x we just found to this one, and we get tan 4.2 equals y over 6.3. So then we get y equals 6.3 times tan 4.2. And what do we get there? Okay, so with calculators, we got 0.46. That's still in kilometers, right? So that's still in kilometers. So what would that be in meters then?
No.
Yeah, you're right. So in meters, it should be about, and I don't know if it was, I think it was 4.62 maybe.
Yeah, it's 4.6.
So I'll fix that right there, and then,
4.63.
so 4.63.
Yeah.
So I'll go 463 meters for y. So 463 meters. So the only thing I have to be careful of is these are two different units, one's in kilometers and one's in meters.